Hi guys, so today we are going to evaluate functions using function notation and XY tables. Okay. So what is function notation? Okay, so function notation is the way a function's rule can be written. It's an equation with the symbolic form f of x. Okay, so something to keep in mind, this is read as f of x. Okay, very important. It does not mean that f is multiplying x. Okay, so function notation, it's read as f of x, and it does not mean that f is multiplying x. Okay, so since x represents our input values, our domain, f of x represents our output values, our y values, or our range. Okay, so let's fill this out here. So f of x here is the name of the function. Okay. Technically, the letter we put here doesn't really matter. We just normally use f because of function, and then after that we probably use g and h, right? But really, you can use whatever letter you want, right? If your name starts with an R, right, it could be r of x. It really doesn't matter. We just generally use f of x just because of function, right? So this here, this x, tells us what to plug in. Okay, we're going to see that in a little bit. But we'll see this x here replaced with a number, and so we're going to plug it in to the rule. Okay, so it tells us what to plug into the function. Okay, then f of x here, like mentioned earlier, this is our output. Okay, what we get when we plug in x, right? So think of it as a machine, right? X is the materials we put in. The f of x, or the output, is what we get out, right? So think of f of x as y. Okay. And then this itself, all of this, the 3x plus 4, is the function or the rule itself. So let's get started. Okay. So first, let's understand function notation using this word problem. Okay. So Lexi had her car towed when it broke down. It cost her $3.50 per mile to have it towed, plus she had to pay a flat fee of $50. The function f of x, again, it doesn't mean multiplying, okay? It's f of x equals 350x plus 50 represents her cost, okay? So here, what does x in the function represent in relation to the word problem? Okay, so x represents the number of miles the car is towed, right? Because based on how much she is towed, that influences the cost she has to pay. Okay. What does f of x represent? So it tells us here the function f of x blah 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 represents her cost. So f of x here represents the total cost for Lexi's car to be towed x miles. So based on however many miles she gets towed, the x number of miles, that influences f of x, how much she has to pay. Okay, so now we're going to find f of 100. Okay, so all I'm going to do here, this replaced my x, so I'm going to take this 100 here, and I'm going to plug it in where I see x. Okay? So f of 100 equals 3.50 times 100 plus 50. Right, so all I did is, since f of 100, it replaced my x, I'm plugging it in wherever I saw the x. Okay, so 3.50 times 100 is 350 plus 50. This gives me 400. Okay, so f of 100 equals 400, which means Lexi needs to pay $400, right? because f of x represents the cost. So if f of 100 equals 400, that means she needs to pay 400, okay, for her car to be towed 100 miles. Why is it 100? Because 100 here replaced my x, and x represents the number of miles. Okay? So let's see it with other things. Okay, so here, evaluating function notation. Again, this is function notation. So first, we're going to determine which function we are going to use. We're going to replace each of those with the input in parentheses, and then we're going to simplify. Okay, so the first one here is f of 4. Okay, so that's my x value. I'm using this function, right, because it's f. I want this function, not this one. This one's called g, right? So here, wherever I see that x, I was going to replace it, right? So here was replace equals, right? So I'm going to replace this x with the 4, and then plus 1. Right? 4 plus 1 is 5, so f of 4 equals 5. And there's my answer. Okay? Nice and simple. Okay, so what about this one? So this one is g of 3. Okay, so I want the g function, and wherever, right, 3 replaced the x, so here I'm going to replace these x's with that 3. Okay, so instead of the x, I'm going to put 3 squared plus 2, and then instead of the x, I'm going to replace it with a 3. Okay, after that is order of operations. So g of 3, I'm not doing anything to it. 3 squared, right, exponents comes before multiplication, so 3 squared is 9 plus 2 times 3. Right? 2 times 3 is 6, so this is 9 plus 6. And then 9 plus 6 is 15, so g of 3 is 15. Okay. So let's try the next one. Okay, so f of 2. Okay. So here, I'm going to use the f function, and I'm going to replace it with 2. Okay. So here, I'm replacing it 2 and then plus 1. Right? This is the f function. Right? Here is the f function. Okay? And then we're going to add g of 1. Okay? So I'm going to replace the x here with 1. Okay? So 1 squared plus 2 times 1. Okay? This was the g function, right? It's g of 1. Okay? So all I need to do is solve. So 2 plus 1 here is 3 plus, okay, 1 squared is 1 plus 2 times 1. Okay? 2 times 1 is 2, so 1 plus 2. Okay, and then 1 plus 2 is 3. So 3 plus 3 is 6. So f of 2 plus g of 1 equals 6. Okay. So here, I'm going to have you try this one. Okay, so try this one on your own, and then come check your answer. Okay, this is what you should have gotten. You should have plugged it in. Right, so here we want the g function, so we're going to replace it with negative 1. Okay, so that's what I did here. Right, this is the g of negative 1. Okay, then f of 1, so I want this function here. I'm going to replace it with 1. Okay, then I solve. Right, order of operations, so exponents first. Negative 1 squared is 1, so that's why the 2 times negative 1 stays the same. Okay, for this one, 1 plus 1 is 2. Okay, then 2 times negative 1 is negative 2, so 1 minus 2, and then plus 2. 1 minus 2 is negative 1. Negative 1 plus 2 is 1, so g of negative 1 plus f of 1 equals 1. Then here is our next one here. So this one is a little bit more complicated. What we see is f of g of 2. Okay. So I'm going to plug in whatever g of 2 is into the f of function. And then I'm going to plug in 2 here into the g function. Okay, so what does that look like? So f of, we're going to do g of 2 first. Okay, so I'm going to take this and plug in 2. So 2 squared plus 2 times 2. This here is the g of 2. Right? So we're taking whatever g of 2 is and we're plugging it in to the f function. Okay, so I'm going to solve this first. So 2 squared is 4. Right? 2 times 2 is 4. And so 4 plus 4 is 8. So really what this means is that g of 2 equals 8, right? This is what g of 2 is. We just solved it, equals 8. And so now I'm taking that and I'm now going to plug it in to my f function, right? So this, we simplified it. Now I'm going to take it in and plug it in to the f function, right? Which we know 8 plus 1. Okay. So 8 plus 1 is 9. So what this means is that f of g of 2 equals 9. So now let's try the next one. Okay, so here this is g of f of 0. So what I'm going to do is I'm going to plug in 0 into my f function, and then whatever I get from there, I'm going to plug that into the g function. Okay. So g of f of 0. So plugging 0 here, 0 plus 1. Okay, right? Because this here is f of 0, right? Where I replace that x with 1. 0 plus 1 is 1. So now I want g of 1. I'm going to plug it into the g function here. So 1 squared plus 2 times 1. 1 square exponents comes before multiplication. 1 square is 1. 2 times 1 is 2, so 1 plus 2, and 1 plus 2 is 3. So g of f of 0 is 3. There you go. Okay. So now what we're going to do is find the value of x when f of x, also known as y, equals 3. So here, if I know f of x is 3, right, I'm going to replace this thing with 3, right? Since f of x is 3, I'm going to replace f of x here with 3. Okay. So 3 equals x plus 1. Right. So here, I know f of x is 3. I plugged it in for f of x equals 3 plus 1. I just need to solve for x. So that we've done before. So here, since it's x plus 1, subtract 1 on both sides. 3 minus 1 is 2. Plus 1 minus 1 is 0. X plus 0 is just x, so 2 equals x. Right? So when my x value is 2, and I plug it in, that will give me an f of x of 3. Okay? So let's do it. Okay. So what about if it's in a table? Okay, we can still do the same thing. So boiling water at 212 degrees Fahrenheit is left in a room. Okay, that is at 65 degrees Fahrenheit, and it begins to cool down. Temperature readings are taken each hour and are given here in the table below. So in this scenario, the temperature T is a function based on the hours, right? So depending on what the hours is, right, that's going to influence the temperature, right? So at the beginning, when it's 0 hours, it's 212. When it's 1 hour, it's 141. 2 hours, it's 104. 3 hours, etc. Okay. So here, it asks for T of 2. Okay. So this here means that the time, right, because it's T of H, this is for H is now 2. Right. So what we're going to do is in our table, we're going to look for where H is 2. That is right here. Which one does it go with? It goes with a temperature of 104. So here it is 104. And what that means is that in 2 hours, the temperature of that water is now 104 degrees Fahrenheit. Okay. So what about the next one? For what value of H, so this time we're finding the H, where we know T of H is 76. Okay. So here's T of H. I'm going to look for where 76 is. Boom. That is right here. What H value does it go with? It goes with an H value of 4. So here, H equals 4. Which means that a temperature of 76 degrees, that happens after 4 hours. Okay. So table, nice and easy. Okay. So let's look at the function. Okay, so here, the function is shown by the graph here. We're going to answer the following question. So f of 1. Right, so we want to find what the y value is. Here, the x value is 1. We want to know what y value goes with it. Okay, so let's start here. So x value of 1, that's here. Right, and when I go up, oh, here, this is a y value of 1, 2, 3, 4. So this goes with 4. Right, so here all my x values are 1. Where does it touch the graph? Right here at 1, 4. Right, so 1, 4. Okay. So here, this time, f of 5, right, my x value is 5. So where is my x value 5? So 1, 2, 3, 4, 5. So that's here. Right. Where does it hit my graph? Right here at -2. Right, so -2. The reason why here is the point is 5, -2. Okay. So can you try the next one here? What is f of -3? Okay, so here the x is -3. That y value goes here with -4 because this is -3, -4. Okay, so try another one. What is f of 0? F of 0 is 2 because where my x values are 0, that y value is 2 in the graph. Okay? So let's try it when we do the opposite. So this time, instead of giving us the x and we find the y, it tells us what the y is. Right? So here is a y value of 0. Okay, so let's take a look. Y value of 0. So y value of 0 is right here. Where does it touch my graph? Okay. So here, this point is -1, 0. So that's one of them. So x is -1. Okay. Touches it here at 1, 2, 3, 4 at 4, 0. So here, the x value that goes with that is 4. Okay, and it touches it here too. So this is 1, 2, 3, 4, 5, 6, 7. Okay, this is 7, 0. Right, so 7. Right, so here, all of them, when the y value is 0, the x value is -1, 4, and 7. Okay, so try the next one on your own. So for f of x equals 2, what is the x value? Okay, so you should have gotten 0 and 3. So when y is 2, it is at this height, right? It's far up. And so it hits it at 0, 2 and 3, 2. So the x values for those is 0 and 3. Okay. That's it for today. Have a great rest of the day. Bye, guys.